Hello everyone, my name is Svetlana. I'm from Higher School of Economics in Moscow, and I'm here to tell you about the research that is devoted to a comparison of the missing indicator method and complete case analysis. These are two different methods of handling missing data. I suppose that complete case analysis, or CCA, should be familiar to everyone. It's a situation when we simply remove observations with missing data from analysis. It is also called list-wise deletion. The missing indicator method, or MIM, in its turn is a strategy when we remain all missing data in our dataset, but assign them a new category and create a variable that indicates presence or absence of missing data. This variable is called missing indicator variable. So basically, we noticed that the number of works that use this method of handling missingness has been increasing for last years, especially in social science. It may be explained by several reasons. MIM allows us to use all given data, and at the same time, its results are very easy to interpret in comparison with multiple imputation, for example. In that regard, missing indicator method is especially valuable in social studies, when respondents may hide some of their characteristics on purpose. So in this case, missing indicator variable may somehow reflect this hidden reason why a person gave no answer. But we usually use methods of handling missing data in order to get unbiased estimates of different parameters. And in spite of all mentioned advantages, current methodological studies in which MIM is examined show quite contradictory results. In some studies, MIM produces the most biased results. In others, estimates are unbiased at all. The problem here may be related to the fact that most of these studies use real, non-simulated data, and therefore results may be affected by peculiarities of this real data. And those studies in which simulated data are used mainly focus on continuous variables, in case of which MIM may not be a reasonable choice. So we aim to fill this gap related to categorical variables and conduct the comparison of missing indicator method with complete case analysis, which is still the most popular method of finding missing data. Using simulated data, we scrutinized how different circumstances affect a bias of parameter estimates when we use either CCA or MIM. Among these circumstances, we had proportional missing data, low, middle, and high, mechanism of missingness, whether data are missing completely at random, or not at random according to Rubin's classification, and the model specification that you can see here. Missingness was inserted in a categorical variable A with 3 valid categories according to chosen proportion and mechanism. We carried out 2,000 simulations for each possible combination of these experimental factors and estimated regression coefficients, their standard errors, F statistic, and R squared, using CCA and MIM on the same data. The results that we obtained are quite non-trivial. First of all, we observed no bias for both methods at any considered circumstances. You can see here that estimates of regression coefficients are exactly the same as their true values that we used when we generated data. So the results are unbiased when we use both CCA and MIM. But when it comes to another statistics, everything changes. Here you can see average standard errors of coefficients in all relevant simulations, and it is revealed that in case of MIM they are much bigger. It means that even though coefficients are unbiased, they are at the same time imprecise and less significant. Finally, take a look at F statistic and R squared here. Again, in case of MIM, we observe underestimated R squared. Considering the fact that all regression coefficients are equal between two methods, we conclude that F statistic and R squared are affected by a missing indicator variable that is presented only in case of MIM. So this brings us to the main conclusion of the conducted research. In social science, where the key objective of analysis is to detect and estimate the relationship between some variables, both methods are appropriate tools for handling missing data because the estimates are unbiased. But when it comes to forecasting, missing indicator method should not be used. Regardless of the factors, the missing indicator variable always turns out to be significant, and its coefficient, which is far away from zero, greatly worsens the model's predictive quality and doesn't allow to adequately understand real predictive power of the chosen variables. So that's all I have. Thank you for your attention.